Hello, welcome everyone. Welcome to the Creating Games with a Tiny Footprint talk. We're going to give you an update on Project Tiny, a quick overview, and discuss the roadmap. And so with me I have Vlad, who is the lead developer on the Project Tiny runtime engineering team. And I'm JC, the product manager working on Project Tiny. Before I start, just want a quick show of hands of who has tried Project Tiny early previews already? Okay, I would say a good half. Great. And for those who haven't, I'm going to spend a bit of time talking about what is Project Tiny, what are our goals, where are we, where did we come from, actually. We'll do a little bit of that, but more importantly, where we're going. So, if you've heard about Project Tiny in the past, this is kind of the key pillars we've set initially when we started on this journey. So, the high-level goal really is to design a new, highly modular runtime that can produce small, light, and fast-loading games and experiences. And so in order to achieve that, we have three main things in mind. The first one is the complete control over size, and I'll go over those three things in more detail. Delivering scalable performance and a robust editor experience. So let's start first with the complete control over size. Current Unity engine and runtime is really, really powerful, but it also packs all the features into one monolithic runtime, which is great when you use all those features, but also carries some unnecessary binary footprint when you want just a part of it. And that's the way Unity grew over the past 15 years that the company has started, and the first lines of Unity were written here, well, not exactly here, but in Copenhagen by the founders. So we thought it was time to sort of think about, okay, where is the future going and what do we need to really address those needs? So one of those first principles was to design a new modular approach, a new runtime that can basically embed the pieces as you need them, but not necessarily all of them. So your load times would be much faster and the runtime sizes will be much lower. So the modularity and the modules that are on the screen are sort of a short list of what's coming into the Dots runtime represented by Tiny. But that's really one of the key concepts we had in mind. Second aspect is really making scalable across all platforms, all types of devices, from small to big, from desktop to servers, mobile, low-end, high-end, AR scenarios. This is kind of one of the pillars of Unity's target initially, but we want to keep that scalability and even make it better, delivering performance across the broadest range possible of devices. And we'll go there step by step, and we'll refine that in a moment. So finally, the last pillar is really to keep delivering to our users an experience when they're creating content that is similar to what you know today, and basically carry on that experience and knowledge to the future. There's going to be some learnings, and we'll discuss some of those, but the idea is really to build on the experience that you've acquired using Unity from the past years and decades, maybe. Not exactly. So that's really the setup for the goal of Project Tiny, the initial pillars we've been looking at to create this new runtime. So looking back, we shipped the first version of Project Tiny, a preview last year in November. And that first release was targeting essentially the web, HTML5, and 2D. We started to demonstrate the capabilities of really implementing a new runtime in a modular way, making it super, super lightweight and very flexible. the first wave of feedback, if you will, that we've heard is that, well, learning dots concept, well, maybe I should go back 1 minute. Project Tiny really builds on top of dots concept. So when you write code in Project Tiny, it is exclusively writing code using dots. So which means all the mono behavior, game objects notions are totally not there. This is really diving exclusively in the world of dots, as opposed to, for example, what was shown at the keynote yesterday with the first-person shooter demonstration, where it's a combination of using dots code and also classic Unity code. So in the context of Project Tiny and this pure dots runtime, it is exclusively learning dots. So learning dots concept is actually an effort you have to invest time on. But initially, the version we delivered with Project Tiny was using TypeScript as a language. And although that was a shortcut to deliver first prototype of where we were going, we heard you. That was a lot to take. So we started to revisit and continue the evolution. So we introduced C# support, but also that brought a breaking change, meaning like any project that you had built with the previous preview of Project Tiny would not upgrade to the one we delivered in May, June this year. But that milestone, delivering the C# preview, was actually a really big one for us, because that was the moment where we actually delivered Project Tiny powered by the dots runtime, the one that was built from the experience of using dots on top of big Unity. At the time, we also introduced a new authoring concept that was a pure dots authoring concept that was sort of departing from the way you would normally create content in Unity. And we clearly heard the feedback at that time, which was, hey, okay, performance is great, Project Tiny goals are very interesting, lightweight, HTML, 2D, all good, except authoring needs to be familiar. And we really thought about that, and this is where we're moving. And so in July, when we shipped the last update for Project Tiny, we also sent the signal and informed our early adopters that we're going to be changing the way you author content, meaning, once again, sorry about that, we've done it again, but we broke the compatibility with the previous version, which means content built with the last preview of Tiny will not upgrade with the next preview. But I think at this point we've nailed it. We've really figured out that the content authoring needs to align with what you know and love. And so at this point, we also heard another round of feedback, which was, okay, 2D and lightweight HTML5 export are great, but in order to have a complete tool that basically answers the needs and what you intended to produce, we need also 3D. We need also to be able to deliver native mobile in addition. And so that's what we're intending to do. And we'll go into more details on how and the way you can work with those targets in mind. So with that journey, it allowed us to not only make a lot of changes and reorient and choose what is the right architecture and the right choices for Project Tiny, but it also helped us to define what is the focus for the next previews. Where do we want to go, and what kind of solution do we want to enable you to build? And so the realization with all the feedback and what's possible with Unity leads us to basically focus on making Project Tiny the solutions to build 3D, 2D, hyper-casual games. So those are examples of typical hyper-casual games made with Unity on mobile. And the idea is to use those scenarios as the main goal, the main target for the first generation of Project Tiny, and the idea behind that is with the same project, the same source code, being able to deliver for mobile, iOS, Android, including being able to pretty much automatically create Google Play instant versions that are sort of ephemeral trials that you can publish on the store, which you can actually do right now with Unity, except with the size limitation that Google is imposing on that type of format. It's actually tricky. It is possible, but it requires a bit more effort. So we want to make that scenario really easy and accessible for you. So next, the playable ads, which is a very important component in this logic of delivering hyper-casual games and being successful in hyper-casual. What you want is really go into a very fast user acquisition, and playable ads have demonstrated that they actually work really well, assuming they're done well. But if they represent really accurately the gameplay and kind of the feeling of your game, you'll be able to capture users from the get-go. Playable ads have some constraints, so they have to be HTML5. They have to consider all the standards defined by MRED, which are the standards used in all the advertising networks. So our goal is to deliver an export that can serve that scenario. And finally, a more general web instant scenario. So for example, running on Facebook network or any other social network that are using basically HTML5 as the way to embed some gaming experience. So to make it, to kind of summarize, this is the web view scenario on mobile that can deliver some content. And so those are the technical targets that we plan to deliver, and hyper-casual sort of define the high-level scenario. So you can expect in the coming month to see us delivering those features step by step. And so with that, I'd like to now give it to Vlad, so cool. You can take over.
Thank you, JC. Oh. Hello, hello.
Yeah.
There we go. Alrighty, thank you, JC. So, as JC mentioned, we've made a couple of changes over the past year as we figured out how to actually best enable this instant, this casual and kind of lightweight use case. One of the things that we've realized along the way is that the way that you want to build games, the way that you want to author, is different than what we need at the runtime side. This is actually one of the challenges that current Unity has, which is that the game objects and mono behaviors are fantastic for quick prototyping, but they're not great at runtime. They are not performant, they introduce a lot of problems, there's a lot of issues around ordering, and all of these things that are generally solved by dots. So if you look back at the first version of Project Tiny, that was really focused on kind of just proving out the initial kind of lightweight use case. The second version, where we introduced the dots editor, we really focused on that runtime representation. And the dots editor was focused on letting you actually edit those runtime components. What you had in the editor was exactly what the runtime was seeing. It turns out that's not great either, because what you need at runtime is not very friendly, not very familiar. You often want to decompose things that you want to have kind of complex on the editing side to give you maximal options. You want to decompose those into individual pieces so you can get the most performance on the runtime side. So right now, we are aligning with the overall dots effort in that we are embracing the game object conversion authoring flow. So what this means is that on the authoring side, you have the familiar Unity editor experience. You author content using the same game objects, materials, mesh renderers, all of those things that you're familiar with. And then there is conversion code, built-in code that we provide that knows how to take things like mesh renderers and convert it to the dots representation, that knows how to optimize. So for example, in a scene, in a level, much of the content is static. Your trees and whatnot are unlikely to get up and start walking around. But you often end up paying the cost of those things actually being transformed every single frame. And instead, the conversion pipeline lets us avoid that. The conversion pipeline lets us lets you tag some things as static, so that in the runtime representation, In the conversion pipeline, it lets us tag those things as static so that the runtime representation is completely flat. And the final output and the final transforms are just what is present. Additionally, you can write your own custom conversion codes. You can have your own kind of very heavyweight authoring components and write conversion code that will then optimize for the runtime representation of those. But that's just largely for the visual authoring. For the actual gameplay code, it needs to be dots. You need to take into account that runtime representation on when you're writing that gameplay code. And that's where, if you saw in the keynote, a lot of the advancements around how you access jobs, how you do entities iteration, all of that directly applies to the code that we're writing here. When it comes to features, when we look at the dots runtime, we are purely in dots land. That means that the features that are supported are those features that are purely dots. Luckily, the work that Unity is doing, all of the new things that we're building, Unity Physics, the dots networking stack, those are all pure dots features, and those will be available in the dots runtime. But there are some features that are still built on top of Unity Engine code. Rendering, in particular, is one area where the current dots hybrid renderer that works inside Unity is tied to SRP and tied to existing functionality. On the dots runtime side, we have components such as the lightweight input system that is really optimized for these lightweight use cases, and same with the renderers. We are going to be working on both a 3D and we have a 2D renderer for these lightweight use cases, but that's specific to the dots runtime. When we look at all of these individual features together, whether you choose to make a Unity runtime, kind of a classic Unity app, or a dots runtime app, one of the things you need to figure out is what features do you actually need. If the target use cases for Project Tiny and dots runtime, such as modularity, code size, instant delivery, are the important things, then you need to choose the dots runtime, which means you're constrained to these dots features. But if you need to access some of the more advanced features that Unity offers, then currently you have to use the Unity runtime. This is kind of one of the first things you need to decide when looking at and when evaluating Project Tiny. But the end result, the high modularity, the individual kind of packages for features, those are all things that we're building kind of current Unity features in mind. So let's look at how all this looks in practice. So what we have here is a typical Unity project. It is a very kind of simple 3D racer. It's built using the universal render pipeline with some simple meshes, not many textures. We wanted to keep this project kind of very simple. And if you look at the inspector, like for example for this boost pad, it's your typical mesh renderer, mesh filter. If we kind of browse around in here, we can look at some of the car AI. There's a prefab. It's got some models inside of it, some components. All of this stuff should look very familiar as kind of a typical Unity project. We can play this in the editor. When we play this in the editor, we are actually using the conversion pipeline, and this is now going to be running using dots hybrid. So this is using the dots hybrid renderer to run the exact same code that we would run, whether it's in the editor or whether it's on the dots runtime side. But because the code for this, the actual gameplay code, was written in a way that took into account the dots runtime, that took into account the constraints imposed by dots, we can also build and run this using the new build settings functionality for the dots runtime. So right now I'm going to do a build for Windows.net. And this is now running in the dots runtime. Same exact project, same exact code. Using our new, very much still in development 3D renderer for the dots runtime. The same project runs on Android. We could do another build here straight with Android using build settings and on the web. The build settings functionality here is not actually specific to dots runtime. It's something that's going to be coming to dots in general and to Unity. And it's a very flexible system that lets you create multiple build configurations directly in your project stored as assets. It's also hierarchical, meaning that one build setting can inherit from another. You can have one top-level setting Or, for example, you can have one core Android build and then do different sub-builds that include, for example, a different ads SDK or that target a different store, all without having to kind of change all sorts of global settings, but instead encapsulate everything there. It's also completely extensible, so you can define your own build components inside your own projects, have your own whatever variables and features, and have those get taken into account when either running the conversion or running the final build. In addition to the build settings, there is a build pipeline mechanism. This is kind of the very simple build pipeline. You can't probably read that up there, but it does kind of very basic entities export and running kind of the final build. But the build pipeline steps are also extensible, meaning you can add steps that will automatically upload a finished package to a web server or to a store, or automatically send up to a tester, or kind of do whatever things you might have done using scripting before. You can now build those things in directly into your project and run them just as a regular build, and also give all of your developers the power to do that. If we look at the actual gameplay code, how some of this stuff is authored, we can look at, for example, this boost pad here. If I edit the script over here, I get taken to this boost pad authoring script. This is what some game object and monobehavior conversion code looks like. This is a very simple one that just exposes the same three fields in the monobehavior that are in the component. Now, you might have seen in the keynote, there was mention of something called generate authoring component. If this was a build that had some of those nice things, all I would have had to do is on this iComponent data, I would have just had to do that, and I would have had that same monobehavior generated. This gives me the ability to author with these things. So if I look at this boost pad, I have this boost pad authoring script here, where I can set values like the speed multiplier, the range, and boost duration, all of these things that you would have in a normal monobehavior, but have these things go straight into ECS. The gameplay code does have to be ECS. So if I look at the other places where this is used, there is a enter boost pad system. And this does a very simple, for every boost pad, look through it, and then for every car, see if there's any cars that are close to the boost pad, and if so, applies the boost. This particular project, we actually have two versions of, one that does not use Unity physics and one that does. The one that does is obviously slightly bigger, but has more features. The cars bump off into each other, there's some friction, all of that. The one that doesn't has lighter features, but it also gives you another example of the kind of things you can do using the build settings. Is you can actually have two different projects that have slices or slightly different gameplay. So for example, if you wanted to build a playable ad from one of your games, you could select kind of one scene or a part of a scene, only some gameplay systems, and only the assets you need for that, and have a very easy way to build a very lightweight playable ad from just a slice of a game, instead of rebuilding it from scratch, like some of you that might be building playable ads are likely having to do today. So like I mentioned, all of this, currently we are targeting Windows largely for development, all the desktop platforms, largely for development purposes. That's where you can do debugging and kind of do your general fast iteration, but also Android and iOS. This project runs on Android, but we're going to show you a video of that because it's hard to demo live. Cool. Yep. As you can see, the renderer here is a little bit different than what you saw in Unity. We're still working on the tiny 3D renderer. It's a renderer built for these specific kind of lightweight use cases. We're using the universal render pipeline as the authoring side, and the renderer will support a subset of universal features. Here, like I said, we're still kind of in development, so a lot of the lighting especially is not where it needs to be. But our goal is to have a well-defined subset of universal render pipeline features available on the tiny side. When you're doing authoring, one of the projects that the Docs authoring team is working on is to actually have a way to give you guidance in the editor what features are supported, what features are going to be properly converted, so that you're not kind of doing a lot of this blind and trying to figure out what will actually work, but you'll actually get some kind of quick feedback saying, this shadow mapping mode is not supported, or this component has nothing to convert to. so that you can build your projects in a way that is compatible with both. All of these things, Project Tiny in general, is built on top of the DOTS runtime. The DOTS runtime is really kind of our future core for running DOTS-based projects. Project Tiny itself is really composed of a number of pieces: DOTS runtime, the core DOTS functionality, 2D, 3D, the DOTS authoring workflows, and then things like DOTS networking, DOTS physics. All of those things are supported in part of the complete Project Tiny package. All of these things are going to be shipped as packages and are going to be available at different times. They're going to be available as these different features show up in preview. But what we do want to do is, especially for this tiny racing project, we want to get this and the pieces needed to build it in your hands soon. We plan on releasing this within the next month or two, to get, well, you know, I can say a month, he's going to tell me 2 months, so we'll work it out somewhere in the middle. We want to get this in your hands so that we can get some of that quick feedback. I should also say to those of you who have tried the previous versions of Project Tiny, thank you, because your feedback that we heard loud and clear on the forums really kind of helped guide us to kind of the path where we are today. And like JC said, I think we've kind of have the right path figured out, where we have kind of the right authoring experience, but can still get the runtime performance and runtime capabilities that are needed. So with that, I'll turn it back to JC.
Yeah, thank you. So I guess the last one is to talk a little bit about where we're going from now. So the journey has been a little bit of a bumpy road for those who started with us a year ago almost. So as Vlad said, we really want to thank you because we learned a lot and you helped us guide where we think we needed to go. But the other thing that happened in parallel is that the DOTS technologies in general matured a lot. And so that gave us a really solid foundation to really now build the Tiny we had in mind from the beginning. So I think it took us a little longer than we thought, but now seriously we think we're on the right track. So as Vlad said, the next preview is planned for before the end of the year, so we're saying Q4 this year. We're already almost, no, not yet actually. We're almost in Q4, so Q4 starting in October. When we have something that is absolutely usable, we'll give it to you for feedback. But expect the scenario, so the project that we showed here will be one of the first demos that we deliver. And one of the interesting things is it's really leveraging the current Unity authoring experience and writing pure code in DOTS. So if you feel like you need a head start and you really want to get into being ready for Project Tiny, the advice we would give you is basically start learning DOTS, experiment, building small samples, go through the samples and documentation. And I know it's not in the best shape that it could be, but still there's a way you can learn. So that's the advice if you're eager to start and want to get a head start. Start learning DOTS in classic Unity on top. Start learning DOTS on top of classic Unity. This is the best way to learn and be ready for when we have this next preview available. Now, what's coming after Q4? It's very much a work in progress. We know where we need to be. What is important in the next few months is to define how we're going to prioritize the different features to deliver on top of the DOTS runtime to serve those tiny scenarios. And so that's why we sort of declare to you today, okay, the goal is to enable you to build hyper-casual games for mobile and be able to deliver both playable ads, both HTML versions. So in one go, you can serve all the needs. Hyper-casual is kind of it's well-defined, but also pretty large scope. So feedback will be also very welcome in order to prioritize the series of features. But we're fairly confident that in the next year, we'll be able to deliver those scenarios, 2D, 3D, and also once we've built 3D, serving AR scenarios becomes something that is fairly doable. So we'll have update on those really shortly. So I guess with that, it's time for questions. we have some time. There should be microphone in the back, right? So, thank you.
Thank you.
Or if you don't want to go to the microphone, you can shout your question and we'll repeat. Yes.
Okay, hi. I have a question regarding conversion from the old Unity runtime into dots, and specifically into Project Tiny. When I downloaded the latest release from Project Tiny, I tried to import old prefabs, specifically the hierarchy in them. Is there a possibility to do that?
So the current version of Project Tiny that's available in packages is actually the old one still. It has none of the dots conversion authoring flow or any of the stuff kind of shown here. So I don't think kind of anything will work there. But as soon as this is available, then you should be able to just bring in your prefabs and bring in kind of even existing scenes, to some subset of the content in there. Should kind of flow through the conversion pipeline almost as is.
Okay, thank you. Any maybe predicted time frame for that?
Next couple of months.
Okay.
Likely next to 1 to 2 months, yeah.
Okay, thank you very much.
Hey, sorry if I missed it, but how about UI in dots? UI to me, it seems like something that doesn't really work with ECS.
Yep. UI in dots is certainly a challenge. The main thing to realize with dots is that dots is really about data-oriented. ECS is one of the ways to get to data-oriented for the data types where it makes sense. For example, for things that are heavy transform-based or mesh-based. But there's other places like UI where you can still apply data-oriented principles where it is not ECS. We have our UI elements team that is actually working on a dots version or a data-oriented version of UI elements at runtime. I don't have an estimated release date for that, but the goal is similar to what I was saying earlier, where you want kind of the full expressiveness of UI authoring. But once you have your UIs built, you want them to be baked down into a highly performant version at runtime. And that's the piece that they're working on, figuring out what that version looks like, how to do that baking, and how to do that while taking into account data-oriented concepts so that you still get the same performance that you expect with the rest of dots.
All right, thanks.
Okay, hi. My question is also about release dates, specifically the Messenger support. Do you have any expected release date for that?
Are you asking for kind of specific support for Messenger platforms or just the capability to make, I guess, Messenger compatible content?
I don't know about the platforms out there which are currently open for Messenger games, so it's probably general.
Our goal is that when the first version comes out, sometime in 2020 when we have kind of the complete package, you'll be able to use kind of the web export to build for the Messenger platforms. Again, a lot of that is going to depend on the type of content that you're building. So while we can control kind of the core runtime size, in a lot of cases you have to be careful with the types of assets that you're putting in. To make sure you don't exceed whatever the size limitations of the platform are. But the core runtime and kind of the core package will be compatible with Messenger platforms at release.
Okay, thanks.
Yeah, and to be clear, to add to that, the reason why there's a big blob for 2020 and not a more precise set of dates is because we are really figuring out at this moment the order of things and what are the different pieces we want and we need for an official version 1. So in the next few months, we will, as soon as things are unfolding, we will communicate more precise roadmap. The only thing I want to add to that is We are in experimental phases, and so if you have a really hard deadline to ship something on one specific platform, be careful. Those things are moving, and this is why we want to be very clear on, we know where we're going, we know in which order we want to basically line up things. How long it's going to take when things will land is still something we'll need to figure out, and in the next few months we'll have answers.
Hello, I'm Ilka, the CEO of Famobi. We're an HTML5 games development company with headquarters in Cologne. So my question is related to playable ads. I mean, there's no right tool where you can just use it and just make playable ads and the build is ready to release. So my question is, you know that playable ads is a very important part of the app ecosystem in terms of user acquisition today. When you plan to make this kind of feature inbuilt in Unity Tiny, you talked about you have your full version of game, then you can just slice apart and make a playable ad out of that. The technical requirements are, for example, that the build should be only one index HTML file. Do you consider this type of technical requirements from ad networks?
Yeah, we do, and previous versions of Project Tiny actually had support for building kind of a playable ads compatible package. On the build and packaging side, I don't really see any concerns there. I mean, it's the first version that we released, you'll be able to kind of build that kind of packaging. For being able to publish kind of just a slice of a game, that will be possible, but it's not going to be a magic button, like in the sense that you will have to actually design the game and the gameplay so that it can be sliced. Meaning that, like, if you want to take out, you know, a particular level with a particular set of gameplay features, you'll have to design that level and those systems in a way that they will work without kind of everything else. But it will be possible to do that, and the end result will be something that you can publish as a playable ad. Unity has our in-house ad group is also very interested in playable ads, and we're working closely with them to optimize kind of the output for playable ads and for that particular use case.
Okay, because my specific question is the output of the playable ad must be different because the requirement is it's just one single index.html file.
Yep.
Okay, thank you.
Yeah, it's definitely an extra packaging step in the build pipeline. But as Vlad said, we're working very closely with our advertising team. Unity Advertising Network is actually delivering playable ads today. Unfortunately, those are not made with Unity. They are most of the time made by hand in HTML, JavaScript, and all of that good stuff. And we don't want that anymore for our customers. If you build your game with Unity, we want to give you a way to easily slice it and get it out. So we're really, really close to what it is to deliver and serve playable ads. So we'll make sure we give you the right solution.
Awesome. Looking forward to it. Thank you.
One thing actually we forgot to mention during the talk, yeah. There's a whole bunch of DOT sessions at Unite. Pretty much all of these are going to be relevant in one way or another to Project Tiny as well now. One of the more interesting ones is probably number 9, the converting scene data to dots. Unfortunately, that talk happened an hour ago, so you can't actually go to it. But all of these talks are recorded, so definitely check that one out online. But even things like Burst. Burst is part of the Project Tiny and Dots runtime build process. So you still get all of the advantages of Burst and the optimizations, even if you're building kind of these small games. So make sure to check out some of the other talks that are happening at Unite. All right, I think that is it for questions.
Oh, there's one over here.
More. Yep.
Yeah, just
yeah, well, we can repeat it.
Try to speak loud and.
So the question was, I showed the tiny 3D renderer, and I mentioned that while on the authoring side we're using universal. The question was whether that's based on SRP or something else. It is not based on SRP. It is a custom written render that is pure dots from the ground up and really focused on kind of the hyper-casual 3D and kind of lightweight instant AR use cases. So separate from SRP, but it will use kind of the universal render pipeline authoring environment for shaders and such, excuse me, for authoring. The second part of the question was, does it support shader graph? We want to support shader graph. There is a very high chance that in the first kind of very release version, though, we're actually not going to support custom shaders at all. You're going to have a set of kind of default PBR shaders, largely so that we can actually really control kind of the final output size. For doing custom shaders, we want to do that with shader graph, but in order to get there, there's some parts of Unity's shader pipeline that still need to be fixed and kind of tweaked in order for us to actually get there. So I wouldn't want to ship a version where we use some kind of custom kind of shader system because we can't use shader graph. So the first version is likely going to be kind of limited, and then the next version will add shader graph support. That's not 100% set in stone, though. We're still kind of investigating a bunch of this stuff because, like I said, shader graph is actually where we want to get to. We want that to be the primary way of authoring shaders, really not just for Project Tiny, but for kind of Unity in general. Yeah.
Does that mean like there will be something separate render thing for AR, or like are we going to use AR Foundation as well for this? Because we're mentioning that render is different, separate. What about the AR? There will be AR Foundation.
Yeah. So the question was basically, what about AR? When and if it will use AR Foundation? We actually had a hack week with the AR team a couple of weeks ago. Their goal is to bring AR Foundation over to Dots and to Dots runtime. So just like with a lot of the other kind of authoring and runtime splits, they're looking how to bring kind of the same functionality and the same kind of modules or subsystems, as they're called in AR Foundation, over into the pure Dots side. The interface to them will be different because ultimately they now need to produce kind of Dots data that you can process with Dots systems. But the same functionality should be available. And especially when we look at, for example, the XR interaction toolkits and kind of some of the higher level pieces, the goal for that is for those things to be able to go through the conversion pipeline so that you can author using kind of the same components, but then convert to something different at runtime. But don't quote me on that because that's going to be on the AR team's side. But that, I believe, is kind of how they're thinking of it. As for when we'll have AR support, I would guess sometime probably early next year, the AR team will likely release kind of a first kind of Dots AR package compatible with Dots runtime and with all the rest of the Project Tiny pieces. It's not going to be as feature-rich as full AR Foundation or kind of the full AR capabilities of Unity right now, but it will be enough to do, you know, some of the more common things, especially for this kind of lightweight use case. One more question? Yep.
Web world, let's say. So in the classic Unity world, you fix the orientation, be it portrait mode or landscape mode. So that means you install the app, then you see if it opens in a landscape mode, then you just rotate the device. In the web world, the topic full responsive design is a huge one for us, especially as a HTML5 game development company. Is this topic something you consider already, or is it too far away for you?
It's something we're thinking of, and like, for example, even kind of our current Android builds, they support kind of dynamic rotation. But it is something that you have to design your content in mind. Luckily, the UI system that we'll be using down the line, UI elements, does have kind of very HTML-like responsive principles. So you'll be able to design a UI that can understand rotation, can understand when it is on a very narrow screen or, you know, very large or whatever the case may be. So you'll be able to do those kinds of designs using kind of core Unity features. It is something we're thinking of, but I mean, nothing to kind of show immediately, although I would encourage you to take a look at UI elements in general kind of in classic Unity to get an idea of what the authoring for that might look like.
Okay, thank you.
All
And
right.
I think we're out of time.
Yeah.
Cool. Thank you very much.
Thank you.